Ladies and gentlemen, please welcome the CEO of the Churchill Club, Karen Tucker.
Hello, it's great to see everyone here tonight. As you can see, we have a packed house with standing or sitting room only in the back. And I'd like to say hi also to our live stream and on-demand viewers. My name is Karen Tucker. I'm CEO of the Churchill Club, and our program tonight is called The Big Data Effect. We have with us a very distinguished group of speakers. Please say hello to Keith Collins of SAS, Gil Elbaz of Factual, Ping Li of Accel Partners, Luke Lonergan of EMC Greenplum, Anand Rajaraman of Walmart Global E-commerce and at Walmart Labs, and of course Michael Chui of McKinsey, our moderator. Welcome all of you, and thank you very, very much for being here. One company stepped forward as lead sponsor of this event, and their help and involvement was crucial to our planning, and their support made it all possible. And that company is EMC Greenplum. I'd especially like to thank Terry Elniski. Please help me thank Greenplum for their partnership and support. And two other special companies are supporting sponsors of this event, and they are Brocade and SAS. Please help me thank them as well. This is our second to last program of the year. Next week on December 13, just in time for the holidays, we present the popular annual Gadgets program with Walt Mossberg of the Wall Street Journal, Kara Swisher of All Things D, Greg Harper, gadget geek extraordinaire, and two tech industry celebrity geek guests. We have the dynamic duo from LinkedIn, the executive chairman and founder Reid Hoffman and the CEO Jeff Weiner, and we promise that you will see gadgets that you have never seen before. Please do remember that Churchill Club is a member-supported, not-for-profit organization with the mission to encourage innovation and economic growth. If you are not presently a member or supporting us in some fashion, please consider joining us. You can learn about the options on our website, churchillclub.org, or give us a call. We appreciate that very much. Thank you. And my last announcement, if you are tweeting, please use the hashtag Churchill Club, and you'll find other Twitter codes in your printed program. It's time now to introduce our distinguished moderator, Michael Chui, and to do that, please welcome our chairman of the board, Avery Lyford.
Well, thank you all for coming. It's my distinct privilege to introduce Michael Chui from McKinsey. As a McKinsey alum, I'm delighted to see fantastic work like the big data report that McKinsey came out with earlier this year. One little-known fact about Michael, big data can be applied to business, but it can also be applied to sports. So if you want to know the point spread of any team, this is the man to talk to. So, Michael, thank you for moderating this for us, and we look forward to a great program.
Thanks, Everett. I really appreciate it, and thank you all. As you can see, we have a tremendously distinguished panel here, so I'll just say a few words of introduction for each of them, and then we'll get right into the conversation. And then we'll also have an opportunity for some of you to ask questions as well, so start thinking of them now. To my immediate left, Keith Collins is the SVP and CTO at SAS, where you're responsible for leading research and development, information services, and the technical support divisions. You led the development of the breakthrough SAS business analytics framework, graduate of NC State. It's the sports that I care about, really. You're on the strategic advisory board for the CS department and also a distinguished engineering alum. To your left, Gil Elbaz co-founded Applied Semantics, which developed contextual advertising products, including AdSense, which was acquired by Google. And then Gil founded Factual, an open data platform and community in an effort to maximize data accuracy, transparency, and accessibility. You graduated from Caltech, where you're on the board of trustees, and also on the board of trustees for the X Prize Foundation, which is very cool. Ping Li, to his left, has been with Accel since 2004, and you're responsible for the newly announced Big Data Fund. You're on the board of BitTorrent, Blue Jeans Network, Cloudera, a few minor companies. And you've also worked at Juniper Networks, degrees from Harvard and Stanford. And then Luke, to his left, co-founded Greenplum and now serves as the CTO of the organization. And you'd also founded a previous database clustering company, an MS in AeroAstro from Stanford, and another degree from Vanderbilt as well, or Vandy, as they say in the athletics field.
Sports guy.
Finally. Anand, co-founded Cambrian Ventures and Junglee, companies which you might all have heard of as well. Junglee was acquired by Amazon. And then when you were at Amazon, also had a hand in the Mechanical Turk, which means I think that you did a lot of things for free. No, I'm kidding. Then co-founded Cosmix, which was recently acquired by Walmart. And so now you're the SVP of the Walmart's global e-commerce and head of Walmart Labs, which is a pretty interesting organization with master's and doctorate degrees from Stanford and another degree from IIT Madras as well. So a tremendously distinguished panel, both professionally as well as academically, as well as represented by their athletic teams, if not by the panelists themselves. But why don't we get started with just a very simple question. I'll stop talking. So we have a tremendously interesting panel here called the Big Data Effect. So let me just start with a quick question for all of you. Why are you on the panel? So go ahead, Keith.
Well, I'd say that I've spent a career at getting data out of systems, right? And it's all been about how do we drive business value by differentiating with analytics. That's all of what SAS has been about. Today, we all are experiencing this explosion that we seem to find the moniker big data. And big data really has this one term in front of it that says use big data. And use big data means apply analytics. So we are actually remaking ourselves for what I'd say is our third major remake, which is rescaling all the algorithms, rethinking the whole process of how you scale to this volume, this variety, this velocity. How do you bind unstructured and structured? So it is critical to our business model right now.
Gil, why are you here?
I really love data. I always have. But, well, when I think about applied semantics that I started in '98, I feel like we wouldn't have been inspired to build this. The original core natural language technology had this third-party data not existed in some form. There was government data, there was Princeton WordNet, there was Open Directory Project. There were all these resources that really made us feel like we could achieve something quickly. And big data to me is, yes, the infrastructure is incredibly important, but it's also the data itself. And so my passion now is in making sure that I can make as much of that data accessible to the super talented folks that can innovate on top of it. I feel like it's going to be the economic engine. And by the way, I think the transparency and openness is also core to building sort of a fabric of democracy that works, that doesn't break overnight like we've seen happen a few times. So I just think there's nothing more important, and I want to see more and more data become accessible. I'm trying to do that as part of Factual, which I co-founded back in 2000. Well, actually, okay, I found it. Anyway.
History will write that. Ping, why are you here?
I heard there's a lot of big data entrepreneurs, and we love to invest in those companies. So, I think our view right now is that big data is one of the biggest transformational changes happening in the data center and the IT landscape. It's one that's going to be a fertile area of innovation for not just the next year or 2 years, but for the next decade. And there's going to be innovation across all the different layers, the layers that Gil talked about and the other panelists here are innovating on. So I think it's one of these opportunities where it happens once in a generation where you can create a platform, companies that can be really that game-changing and create multi-billion-dollar outcomes. So I think it's an exciting time to be investing in this space.
Luke?
Yeah.
Other than the fact you had a product announcement earlier, how did you end up on the stage?
I could say, yeah, it was accidental. I just happened to be in town. But actually, I think we really are in a special time. I think when we worked on making databases easier to use almost a decade ago, it's hard to put a human face on what a database does. But now I think everybody's touched by big data in some manner or another. And I'm happy to say that we're really part of a growing sort of revolution on how to do that work within Greenplum. So I think it's just really fantastic to see the time finally now when we have a new career in the form of data science, and we've got people, my own background is in doing big science work, and whether we're designing stealth airplanes, which it used to be important, or if we're finding ways to make people much happier in their lives and more productive, I think it's really fantastic to see all this coming together. So it's nice to be here.
Right. Anand?
No, I've been involved with data before it was called big data. It didn't seem small to us then. It seems small now, 20 years ago. But the big data movement itself, I'm involved in kind of three capacities. First is, as a practitioner, as an investor, and as an academic. As a practitioner at Walmart Labs, I work at the intersection of three big sources of data: social, mobile, and retail. Three big sources of big data. As an investor, I was an early investor and board member at a company called Astrodata, one of the biggest competitors of Luke's company, ended up being acquired by Teradata, and many other startups in that, that are kind of innovating in that space. And as an academic, I teach the data mining class at Stanford, where I've seen a growing interest, growing number of students wanting to learn about how to mine big data and do interesting things with it.
Super. Well, why don't we get started? We've all talked about big data, but what do we actually mean by that? So maybe I'll invite Ping. You have a fund that's about big data. What do you mean by big data when you talk?
Yeah, as much as we named a fund after big data, I think in many ways the name big data is only captures part of the transformation that we're all talking about here today. I think volume and size is great, and I think McKinsey wrote a report about all the petabytes are going to be generated over the next many years. I think that's only part of it. I think a lot of what's interesting in this big data movement is the types of data that's being generated and extracted and also analyzed. I think it's less about the traditional columns and rows and structured data and moving towards a world of very unstructured or semi-structured data. And that data is not just coming from databases, but it's coming from machine-generated data, user-generated data, open data, and the ability to kind of put all that together and actually get value out of it and build new applications and services. I think that's what really big data is about. It's about taking data that were previously not around, mixing them with data that previously didn't mix together, and then coming up with new ideas on top of it, and many times in real time as opposed to in kind of a delayed fashion and being predictive. So I think big data is a good word in the sense that it's the one that everyone can resonate well, and it's short and it rolls off the tongue. But I think there's so much underneath it that makes it such a rich area for innovation.
Well, Gil, maybe I can turn to you. I mean, there's big data, but then we've also talked about open data. Sometimes we talk with companies and say data is very valuable, and others say data is becoming more of a commodity, right? So I'm curious on your thoughts there about how valuable is the data itself, and what does it mean to have open data?
Dang, that's the exact question our board of directors asks. It's a really hard question to answer. Exactly how much the data is worth, because then there, if you knew, then you could price it exactly right. It's tricky because, well, we all know data gets any good gets priced with supply and demand curves, but in the world of data, there's not really a consensus in terms of exactly what the metrics are. There's less transparency in terms of what measures do we use for quality. A lot of the companies that have data don't make it so accessible so that it can be rated by consumer reports. So what we think is that the more you move to open data models, the more it becomes, there does become transparency around it. And you can start to have external groups that qualify the goodness. And then you start to see real liquidity, real markets form, and you get to have a better firsthand view of the value. And of course, fresh data is always worth more than stale data, so there's this commoditization cycle. At Factual, we just want to make as much of it open as possible and try to bring the prices down for the innovation to happen.
Can you talk a little more about what are the sort of business models you get when you have data of different types, different freshness, different scarcity?
Right. Well, let's see. So what is open data? So first of all, Ping was mentioning that big data is there's not a perfect definition of that. Open data also is something in search of a definition. The way we think of it is it's much less encumbered than the data traditionally has been from data vendors. It's more transparent in terms of you get to play with all of it before buying. It's easy to access via download or via API in any form and format you want. And it's also, we think it should be community built and community driven, sort of like, well, sort of like open source, a GPL model which encourages contribution back. So that's kind of a little bit of a answer to your previous question. I mean, in terms of what you do with it, well, we're just seeing tremendous amounts of opportunity around location-based services because of the data we have is, a lot of it is around a global place database. So that's where I have personal experience seeing a lot of innovation happen on smartphones, new location-based services that let people explore and interact in new ways with all the businesses, places, people around them.
So what does that mean? What's in the database then?
What's in the database?
Yeah.
Oh, so Factual was founded to make this open data platform agnostic and to work on a lot of different verticals, but the one where we've received a lot of traction, customers like our global place database. It's 55 million businesses, points of interest, doctors, restaurants, you name it, around the world, almost 50 countries. We've only been able to build it because of this contribution model. And we have deep data in a lot of categories like restaurants. We might have 30 or 40 attributes.
And how many people work at Factual?
About 45.
About 45. So Keith, there are a lot more than 45 people at SAS, right? And it's well known for being a place that's people like to work, right? Lots of awards, et cetera. But one of the things that we identified in some of our research is a bit of a looming gap for talent, right? A scarcity of people who can derive insight from large amounts of data, from big data. I'm curious about what your perspectives there are.
Well, there's probably two trends that I think are happening right now. And yes, everybody really understands that as the discussion emerges, that there is a huge gap in talent for people who can understand how to apply analytics appropriately. It really is about being able to establish the right hypothesis. This is why we couldn't, years ago, put analytics in a black box that anybody could use. Is you have to have enough knowledge of the context of the domain to ask the right question. And that really, so the good news is, I think every university globally right now is trying to figure out how to push their programs through. 3 years ago, we funded a new program at NC State for a master's in analytics that was based on an idea that you needed a practitioner program. You needed one that focused on the skills across the industry, so you got a good perspective that you learn to apply not just the data mining, the predictive analysis, but also forecasting optimization. So we see all three of those as core to something that you need to be approaching. Just last week, I had a conversation with EduCause, and they've decided to remake themselves, no surprise, that analytics is going to be one of their core messages.
What's EduCause?
EduCause is a foundation around IT for education. So they work with a lot of CIOs, and they're asking the question, what do they need to do? How do they really drive analytics into the educational system? And they said, well, we were voting online. We have a panel that we're setting up and talking about the issues. And skills gap came up the number one issue over the ideas of technology, over the platform deployment, over the culture issue. It was all around skills. And I said, look, as an educational system, there's no way you're going to compete for the talent gap. So what are you going to do as an investment strategy to begin to teach that, skill that up? And I really think that's one of the important messages is people have to understand. And this is about retraining internally, bringing those skills in, because you're not going to find a lot of that in the open market right now. 3 years from now, as more of the schools skill up, you'll have that opportunity. The other thing that's shifting, and we see it in offerings from SAS, and we see it also with a lot of the new VC-funded entrepreneurs, is removing the packaging of tools and putting it directly in the business process. So if you look at what we're doing in markdown optimization in retail as an example, or marketing optimization in customer intelligence, or credit risk for banking, it's about putting the analytics, using our skills and our talents to put that in the business process, in the workflow, so that the user using it is just using the business process. They don't know about the optimization, the estimation, the forecasting, the modeling that's going on behind the scenes. So there's one, address the skills gap. We're going to need it. All the companies that are providing this are going to need that almost more than their customers themselves. And then you're going to see a lot more of it put directly into the applications that get delivered.
Does this a skills gap resonate with other people? You all have a...
Yeah, well, I think we see, first of all, there's a certain urgency around big data right now. I think every business is looking for ways to get a tighter connection with their customers, and the notion that you can predict what your customers are going to do and then move them along a trajectory is becoming a bigger part of businesses now. So the call for data scientists is huge. And Keith and I were talking about this. SAS has a large worldwide following of people who are data scientists. They just may not be called such. And
what is a data scientist? What does that mean?
Yeah, and so people. I'll say that Joe Hellerstein I'll quote him on this. Calls them six-legged insects. They're basically people who have a set of skills both on the ability to get data, to reason with it using statistical methods, and to sort of share or tell a story around that data in the end. So, having people who have domain experience sufficient to tell those stories and be able to leverage their skills with data are data scientists. And I think as the tools have evolved and become tremendously more powerful to get more data sources, I think those people who already have some of those skills are ripe for being leveraged, even having greater efficiencies. And so finding those people within organizations, helping them learn about these new abilities, I think is one of the untapped areas we're looking at.
I'd like to pile on that for just a second. These people do exist in a lot of the organizations right now, and we need to find a way to not have the debate about whether they should be in IT or in the business unit. Right now, the demand is how do you collaborate? And so the work that Greenplum's been doing on this whole idea of collaboration, I think, is an important thread that's going to underpin a lot of what's important for us to act on, which is find the skill, get them to collaborate, get them to work across the organizational units. Because if you take most organizations, they have some expertise in forecasting, in the manufacturing side maybe, and you got in the marketing side, you got people who understand behavior modeling, and it's getting those to cross those boundaries, which is where you're going to get some real new ideas and some new sense of what you can do.
Anand, I see you raising one of your 6 legs.
So, one of the interesting things that I see, at least, from an academic point of view as well, is that it's not that people don't know how to work with it. There are a lot of people who work with data already. There are data scientists out there. But what's fundamentally changing now is that there's a lot more data. And when there's a lot more data, the kinds of things that you can do with it and the way you work with it sometimes tends to be very different when there's small amounts of data. The kind of tools that you use tend to be very, very different when there's large amounts of data. Many of the fundamental algorithms that have been developed, the machine learning algorithms, the predictive analytics algorithms, for example, depend very crucially on data being in the main memory of a computer and then the single CPU accessing it. This is at a very fundamental computer science level. And big data breaks that condition. Right? So the data can't all be in memory at the same time, and it has to be processed in a distributed fashion. So this requires a completely new programming model, a completely new way of thinking about data, and the kind of things that you can do with it. When I teach at Stanford, for example, I see a lot of students who are really, really bright students who can do machine learning and artificial intelligence kinds of things. But when I tell them, look, you try to do the same thing, but now you have 10 terabytes of data, the first thing they do is sample the data, right? And that defeats the purpose. So I think the whole point is how do you do all these wonderful things without sampling the data? That's what big data is all about. And there's a lot of new technologies and new fundamental algorithms, computer science techniques that are being developed to address this. And we need a lot more people to be working on those things.
Yeah. And I'm seeing this, it's not just a big company thing. Every startup that we invest in, the data scientist role is becoming that much more important. I think a lot of it's because big data, the big makes it seem like it's only a small number of people that actually have this problem. But what it really is big data is getting democratized. It's democratizing data to every single application, every single type of company, which I think is what's exciting. So even the startups that aren't at the scales of some of the companies EMC deals with, I think they are finding that the data scientists are the ones that are helping driving product innovation. They're the ones driving monetization. If it's an ad-based company, they're being used for a lot of things that traditionally were just either product managers or an ad guy, the ad ops or something. These are now data scientists are sprinkled throughout these organizations because people are leveraging data for all aspects of the business. I think that democratization is a very powerful trend. And I think we'll continue to create more need for data scientists, not just as data scientists, but the guy that can do that plus product engineering plus ad operations or whatever the heck it is.
So are you investing in cloning technology?
Yeah, I wish. Make some money doing that.
Well, look, maybe we could turn to you. The statement's been made that this is becoming relevant all across the economy. Can you talk a little bit about where you're seeing, you have this view in terms of many customers in different places. What are the sectors which are ahead? Where is there more opportunity?
Well, I think there are those who have been traditionally big users of data, which include, retail and telecom and intelligence communities, the bad guy version of the marketing problems. Those have good experience with big data already, but I think mobile social, right, even though there's a large degree of data usage there, I think there's a starvation for data sources in mobile social right now. And so we're seeing some activity around freeing up some of the data around geolocation, making it more available. And so when Gil talks about open data, that's an interesting angle, crowdsourcing some new data sources in those, at which point there is going to be a continuing explosion. We're watching an explosion in action on mobile social. But that said, I think there are some under-penetrated or underserved communities. I think healthcare is one. I used to call it the electric third rail of like a startup, doing business with healthcare. Too hard, don't bother, it's going to take too long. And I think now, when we look at healthcare, the thing that's happening is there's a fundamental change similar to, I think, what happened in retail. When customers would come up with an iPhone or Android device, they would know more about the retailer's products than the retailer did. And that asymmetry of power started to get retailers to move more quickly to get closer to customers. I think the same thing's happening with healthcare. I think patients are starting to take more charge. So when they show up at a doctor's office, they do know a lot. And I think healthcare providers are starting to factor in a lot more with regard to analytics. And we're working with several of them now, partially just because of our volume, our size. And I think with healthcare, we also have government services. So, we have a couple of, we've done this Data Heroes Awards, to kind of recognize pioneers in doing these kinds of works. And, I think one of them is Nathan Wolf, who's here, and does the global viral, calculations to figure out where these sort of pathogens might spread and factoring new data big data methods into those kinds of government services is going to start to create an even bigger ecosystem. So I think there's under-penetrated markets. We're very excited to see those start to light up.
Others on the panel, where do you see opportunity?
The way we do science, for instance, is going to fundamentally change. This is a completely non-industrial application of big data, but it's the way science has been done has evolved over the centuries, right? First, we started with empirical science, observations in notebooks, and then people use those observations in notebooks to come up with theories, right? So that was theoretical science. And then of late, those theories were too complicated, so we had to simulate them using computer algorithms, so we had computational science. Now, data is now the fourth paradigm of science, right? So this is a famous quote by Jim Gray, one of the early pioneers in big data. Data analysis and data-intensive science is kind of the fourth paradigm of science. It's the new way that science is being done. In all the sciences, ranging from earth sciences to physics to chemistry to biology to whatever science you can think of, sociology, psychology, there's more and more data. And science is becoming more and more about collecting large amounts of data and doing analysis, right? So the Isaac Newton of the future is not going to be locking himself with a notebook and trying to figure out equations. He's going to work with, Hadoop and be trying to do some analysis to figure out what the relationship between things is. So what we call a scientist is changing in the new world. And I think that's fundamentally one of the things that's most exciting to me beyond the industrial applications of big data.
So when you talk about there's a lot of interest. Everybody wants to understand sentiment analysis, social media analysis, and that one's really easy for people to understand. One of the breakouts for us this year, we're going to grow probably 370% in fraud across all industries this year.
You will grow in fraud.
Fraud, right? Because what happens is in the downturn of the economy, great thing about analytics. On the upside, right, everybody's acquiring customers and using analytics to customer. On the downside, it's about risk and fraud. And the change in the data that you have now completely changes, so the compute speed for doing link analysis, where you use social network analysis to find influencers, you turn that upside down to find fraud. So we're doing, LA County, finding child care fraud. We're finding, check kiting, credit card fraud, and tax fraud. Tax fraud is actually a great one. I'm actually really proud that we're doing more of that because I don't want to pay more taxes because somebody else isn't.
Get on that.
So a tremendous amount of breakout around fraud right now.
Great. Gil?
I was going to add, I think we can't have enough community that supports the data-focused, the data scientists. Luke and team are doing some really interesting things in Greenplum and creating sort of a social layer that lets people collaborate, that have ideas, that see patterns, that want to discuss them with other people, that want to discuss statistical approaches. Similarly, I got to get involved in a project called Kaggle, which is an external community of data scientists that any company can tap into, and people are literally competing with each other on a daily basis to extract more insight than the next. And I think these are the kinds of things, whether internally or across the web, that really make for a great dynamic.
I think what's intriguing about that, Gil, is turning it into a game. Kaggle is almost like a game. It says the winners are competing for the reputation to solve these hard problems, and I think we're going to see a lot more of that, penetrating this marketplace.
Yeah.
It's fun.
The coolest thing is it is very cross-disciplinary. It's really surprising to hear in Kaggle how a person that figures a pattern out often doesn't have the domain expertise in that area. There's a big $3 million prize to detect. It's a preventative healthcare prize, a heritage prize. Basically, you're predicting who's going to have a heart attack or stroke from a large set of patients. And they say it's probably not going to be. It's probably going to be a physicist that wins. So it's just really interesting, I think.
It's also just building off the Kaggle comment. It's amazing how global this phenomenon is. One of the things that we've seen across our partnerships in different offices is the adoption of some of the big data technologies is happening faster in some of the emerging markets where they don't have maybe some of the legacy database and data management frameworks. Open source projects are much more cost effective. They're using commodity servers and storage already in some of those areas. So we're seeing a lot of demand for some of these big data technologies in places like China and other areas, regions where they're less encumbered. And if you look at a lot of the Kaggle data scientists, they're all over the world. This is not a Silicon Valley phenomenon by any stretch. I think, if anything, it's a global phenomenon.
I resonate with that. I was in India recently, and one of the biggest sources of data is this. There's this project going on to provide a universal identity to every citizen of India, right? And that's and associate biometric data with that. Now that is one of the largest, biggest data projects that's out there. So it's truly an international phenomenon.
So interesting that you bring that up because I think one of the topics that often comes up with big data is around privacy, and so. I don't know. I'd be curious what your perspectives would be on privacy, given that big data, a lot of it is about people.
Right. One of the most interesting sources of big data out there is social, right? So social data is one of the biggest sources of data out there. The interesting thing about a lot of social data is that it falls into two areas, right? Either it's publicly shared with everybody in the world, like Twitter. When most people tweet or when I tweet, our implicit contract is that it's visible to the whole world. You can do what you will with it. And the rest, and the other is the Facebook model, where the data is owned by the person, effectively, who created it. Right? I own my data, and you have to explicitly get my permission to do certain things with it. When you talk about privacy, I think the key is that there is a contract between the person who owns the data and the person who uses it, and the owner of the data has to provide informed consent on how it's going to be used. And for example, to use an example, right? We recently launched a Facebook app from Walmart called ShoppyCat. Just launched it last week, so it's top of mind. So what this app does is it's a gift recommender app. You install it, and it looks at it acts as your agent on Facebook, and it tells you, gives you gift suggestions for your friends. What gifts can you get for your friends and family based on the interest that they express on Facebook? So clearly, it's using social data, but it's doing so as your agent, and it explicitly tells you, look, I'm going to act as your agent. I'm going to look at what your friends are sharing on Facebook, and I'm going to make gift recommendations for them. Are you okay with that? Right? And once they say okay, then it's okay to act as their agent. And we have to be very careful not to use the data for any other purpose. Right? We have to be very careful not to use the data for marketing purposes or for other analytics purposes. We have to be very careful to use the data for the purpose for which you got permission. So that's one. On the other hand, there's public data like Twitter data. You can do pretty much what you want with it because there's an implicit assumption that the person knows what they're doing when they're tweeting. So, for example, one of the interesting uses we are doing there is we're using that to determine what new products we should be carrying at Walmart that we are not currently carrying. right? One of the most interesting things analysis we did was we figured out there was this new product called Cake Pops that I hadn't heard of that we saw really taking off, and now we're going to be carrying Cake Pop makers at Walmart based on the fact that a lot of people are tweeting about Cake Pops. And so that was pretty, that was an interesting insight, or the flavor of vodka that we should be carrying more of, and which location should we be carrying it in, right? So these are insights that you can get from public data without any privacy concerns whatsoever. So there's these two camps.
Keith, any perspectives on privacy?
Well, I just want to make sure I understand one piece there, because one of my concerns, especially if you look at what's happening in the EU, is they are looking at whether or not they should legislate exactly. You have to say how that data is going to be used. You can't use it any other way. One issue I have with that is if we head down that path, yet we miss the public good. So all the healthcare data, when you really can anonymize it, that lets you understand better healthcare outcomes, understand the chance for cancer, and all these other issues. If those laws are written in such a way that we cannot do that, that's a big problem for us. The other is, one of the things about analytics is you don't know until you ask the question, until you've done the discovery. So it's really hard to have legislation that's in place that prescribes the only way that you use data to good value. So I think we have to be really careful about how we govern ourselves and try to avoid legislating exactly how we're going to use that data. And the other is, right, when we walked into a local store, we really want people to know us. So if you walked into your local hardware store, they knew who you were, and they knew about your family, they knew what was going on in the community. What's different now, right? All we're doing is it's easier to do that. We can do it from the same perspective, but it's know me, so I'm just like, get over it, right? I want you to know me. Don't spam me with anything I don't care about. And it's like you say, as long as I've made that publicly available, great, let's go for it.
Everyone else believe in the get over it perspective?
Personally, I don't know, but certainly
but for everyone else.
There's evidence like Mint.com, people entering all of their passwords and getting back those services. I think the other thing interesting is crowdsourcing of data. I think there's sort of this overwhelming feeling that people, when they contribute, they get something back, and that's an interesting evolution of the way people might look at, say, healthcare. Somebody was saying that most of what's tracked is diagnoses and prescriptions, and procedures, but not outcomes. So if you had that outcome data, you might make different decisions about what kind of therapy to choose.
So we've talked a lot about the tremendous potential that data has and that big data has and all the things that are going to happen in the billions of dollars of value. But some people say, well, maybe we're kind of a little bit in a hype cycle, right? Maybe we're blowing things over a little bit. So, Ping, I'd love to get your perspective. Are we hyping things here, and what's real and what's a little bit too much hype?
I sure hope not. We just have a $100 million fund launched a month ago. So, I actually think, I think we're very early days in this big data transformation. I think there's certain parts of the stack or the layers that have, received a lot more attention than others. I think, obviously the stuff around the kind of the data management, the data platforms, like what EMC is doing, Cloudera is doing in the Hadoop space. I think that area has gotten a lot of attention. And I think there's still more work to be done, but I think it's probably the first area of investment that has happened. And I think, there's more to be done, but our view is that there's still a lot of stuff around the data management, the data platforms that is as interesting or more interesting, right? I think a lot of the applications that ride on top of these new data platforms have yet to be invented, right? I think people are porting, legacy BI stuff on top of this stuff, or legacy ERP apps and putting it on top of the big data platforms and calling it big data. I think what you're going to start seeing going forward is innovation, native applications for big data. So what's the Siebel of the big data world, or the Cognos or business objects? Take all the stuff that's been built over the last 3 decades, and what does that look like? With the new capabilities, right? So I think that's where I think the innovation is. I think we're just starting to see the seeds of that happening. Entrepreneurs are starting to realize the potential of the platforms, and what happens, they'll build these new apps or services, they'll break the platform, and that'll start innovation in the platform again, and it'll just be this sine wave that goes back and forth. So I don't think we're in a hype cycle. I think the environment right now couldn't be more fertile for innovation. Valuations could be a little higher than I like, but
The way I think about this is big data is at a stage where the early innovators are out there trying to figure out the use cases and the application. And in a way, it reminds me a lot of the early days of, let's say, e-commerce when Amazon was out there, right? Now, Amazon had, when we were at Amazon, had to figure out a lot of things, right? We had to figure out how to do fraud detection. We had to figure out how to do payments. We had to figure out how to do ratings and reviews. Now, each of those is now a big company that's providing that service, right? So independent, so each of the things that Amazon had to innovate on its own because we were an early pioneer is now an independent company that provides that service to a whole bunch of other people. So I think we are in a similar stage in the development of big data where the early pioneers are going out there and finding out the true use cases and finding out the cases that really make a big difference. And then each of those use cases will then get commercialized and will become a big company on its own. So that's kind of the stage that we're at.
Does anyone on the panel think that there's a place where there's been too much emphasis?
Too much emphasis on Hadoop. There's a danger, and it depends on how fast companies, like with the Greenplum UAP announcement, maybe we're going to see enough maturation in the management of that framework so that people don't get disillusioned. But those who are just standing up Hadoop as is, with no management framework, writing directly to it, not recognizing the collision they're in, going to run into in the next 6 to 12 months in terms of managing that and the investment they're making, there's going to be some real disillusionment there. So it's really how fast does the cycle go to mature Hadoop, and does it stay ahead of because there's everybody's climbing that bandwagon.
So I kind of get this picture of a box of sharp little knives that somebody left in the kindergarten classroom.
There you go.
I mean, clearly the box of sharp little knives can be used to make fantastic art, but it more often than not results in a bloody mess. And so it's kind of the tools are powerful, but when used improperly, they can yield unpredictable results.
Ping has a lot of money in these sharp little knives.
Yeah, we like sharp knives.
In the right hands.
I think the train has left the station in terms of Hadoop being a very powerful data management platform. But I agree with the other folks that there is still a lot of work to commercialize Hadoop and make it enterprise ready or digestible by a broader mainstream set of users, right? So I think once that maturity happens, that's when you'll see a lot of these applications start to emerge where people can really harness the value of the platform. But I don't think there's a question whether it is going to be a valuable platform. I think it's how it's going to be directed and how it's going to evolve. And companies like EMC and Cloudera are spending a lot of time trying to put the boundaries around the product and drive value.
Gil, are you playing with knives?
No, but I do advocate juggling knives. I mean, the opportunity, there's a combinatoric explosion of data and APIs and services that you can mix and match, and many of them simply haven't been tried yet. So depending if you have a certain domain expertise and understand your area, the potential to leverage Twitter in a unique way or data that we're generating, there's just a lot of opportunities there that haven't even been tested, so that's why we're seeing, I think, just a raft of. I don't think that right now we're in a hype cycle yet, and there's a lot of quality startups getting generated, improving data in different areas.
So I'm curious. I mean, how vertical do you have to be in order to take advantage of big data? How much do you have to understand domain, and how horizontal can you be? Right? Hadoop. You can apply everywhere, perhaps, or something like that. I'm curious on the perspectives of the panel.
I think the new machine learning capabilities. There's a lot of discovery that happens, in the big data infrastructure that we have now. So I think one of the really strong drivers is getting at the data earlier before it's sort of structuralized. And you can learn things with advanced algorithms. And we talk about big data. I mean, interesting case with SAS is only 30 gigabytes of data on variable selection can take 27 hours to compute which variables, say you have 1,000 variables, you want to know which of these variables are going to be useful for predicting some outcome. And very powerful techniques can be brought to bear which say these are the 6 that matter. And now with our advanced technology, we can do that same 27 hours of work in 60 seconds. And with that transformational capability, we can now discover more. And so the domain expertise, while it's critically important to telling that story and connecting the dots, I think you can discover more about the business. In fact, our data science team does this all the time. They'll end up telling the executives more about how their business really works than they knew when they walked in. So it's fascinating. I mean, it really is a science in that sense. It's a process of discovery.
And it's not that far away, coming to you December 20th.
Not that was a plug. Anyone Anyone else? Thoughts on horizontal versus
I think many of the fundamental tools and techniques are horizontal. That for example, that I teach in my data mining class or in my textbook, for instance. But the way they are applied and the way they are combined are truly horizontal, vertical, and they depend on the use case. So it really is a combination of the two. There are a few building blocks that are truly horizontal, and Hadoop is definitely one of them. And there are other algorithms that run on top of it that are truly horizontal. But the true value you get is when you combine these with a lot of domain knowledge. Right?
Great. Well, we have an extremely distinguished panel here. It's interesting. We've mentioned Nathan out there, and Kaggle actually is represented in the audience. But I'm curious. I presume there might actually be some entrepreneurs in the audience who would be interested in knowing what might be a good place to invest. So I don't know, Gil, you're an entrepreneur. If you look at the big data space, where are the places that are interesting for someone who might want to start a company?
So I had mentioned this combinatoric explosion of APIs that are available. We're just seeing so many interesting things on the local space, new ideas all the time. I'm helping individuals on the mobile space interact with the opportunities around them. I think certainly there's going to be a major shift in the way people buy local services, find local services. We've seen that maybe there's a coupon bubble perhaps right now. But I think it's a bubble that's going to, maybe it'll deflate a little bit and then expand dramatically, because ultimately if you're walking down an aisle in a supermarket, why aren't all of these products calling out to you and offering you and trying to get your attention? Or why isn't the supermarket next door asking for your attention? It's something, I don't know, it's over $1 trillion in, I don't know, I forget the exact number, but it's a large local commerce number, and there's going to be many, many new innovations in terms of how you interact with the consumer.
Ping, thoughts about where an entrepreneur might find some real traction?
Yeah, as I said earlier, I think there's many different layers, and just mapping on the historical stacks in the enterprise and applications and figuring out how they can be reinvented in the big data world, I think is very interesting. We recently working with a seed company that's trying to how to think about the CRM world if you take the digital wake, and how do you harness that data to build a better application around that. So I think there's lots of areas. One thing that I haven't seen as much of, and I think is very interesting, is the intersection of mobile and big data. I think mobile is the single best data capture device out there, and generates a ton of data these days thanks to iPhone and Android. And how you can harness that data to create really intelligent applications or different applications and services, I think is a really interesting thread that could be riding two very powerful trends.
Anand.
So following up on that, mobile location data is actually a very interesting source of data, and it's in addition to being big data, it's potentially also fast data. And one of the ways to think about this is think of an application like tracking a fleet of trucks or something like that, and knowing their location all the time, right? If you think about the location technologies that are present today, they can track a small number of objects at very high granularity. But imagine if you had millions and millions of things whose location was available in near real time, building the infrastructure to track that and do that well, I think that's an open and interesting, challenging problem that has lots and lots of commercial applications. So that, I think, could be an interesting space for both for startup and for academic research. Another area that I think is fertile is how do you combine public data and private data and get intelligence from that. I think that's going to be a huge space. And I know of a few startups already who are working in that space, that are trying to figure out how to do that. And the challenge there is that you have these two really big data sets. There's this huge amount of public data that's out there. That's in huge amounts of petabytes of public data growing every day, including Twitter and including all the news open data that Gil was talking about. At the same time, the private data that the company has is also huge. How do you sort of intersect these two huge amounts of data? Either you have to take all your private data and move it out in the cloud, which has security implications, or you have to take all that public data and bring it inside your company, which is hard because you have a very thin pipe. So figuring out exactly how to intersect huge amounts of public data with huge amounts of private data, I think that's both an interesting and challenging technical problem to solve, as well as an interesting area for startups to innovate around.
We've talked a little bit about some of these business problems. Keith, I'd love to hear from you, and you've mentioned a few as well. Where are the real business problems that big data can make a big difference in?
Well, there's a couple of these are great. The shift in marketing to digital marketing is really big, and your comment about the flow of data. So a lot of the data is going to live outside of your organization, and there's a lot you can do with that, and there'll be a lot of service providers that provide that. But binding that back into your organization with the data that you have becomes yet another service that has to emerge. The whole energy sector, power distribution, smart grid, that's going to be a huge opportunity and space for people to innovate in and grow. And then the health and life sciences, one of the explosions of public data that's really going to take place is the collection of health data that's about hospitals, about EMS, about treatment centers. And those people who find the unique ways to discover something there that they can drive a whole new space, I believe, either in treatment centers or in public care. So I think we're going to see, while money's slow to flow that space, I think it's going to be one of the interesting areas to innovate in.
You mentioned the intersection of smart grid and big data. What does that mean? What's going on there?
Well, one of the simple ones that we're already seeing is classic legislation that said we're going to put in the smart meters and you're going to change to do forecasting on a 15-minute interval, even if it makes no sense. Okay, well, these are like so many different regulations. The leading innovators take a regulation where they're having to collect something and having to use the expense any rate and change that to value. So we saw that when Basel II hit Europe and they're having to collect all this information about risk. Well, how do you turn that into a value proposition about better running my business? So one of the places I suggested that VCs and entrepreneurs look to is follow regulations. There's almost always an opportunity to take that regulation and turn it into a value proposition.
Yeah, that's really interesting. I mean, a couple of more people that are that are here tonight. Silver Spring Networks, another Data Heroes Award winner, and Sirius Energy. And the notion, it's so early. That's another underpenetrated market. We do live in California, so we have a little bit more of a disproportionate focus on green energy. But I think what's happening in homes, new home construction, commercial building construction, and smart grid, smart meters, is only at the very beginning. And so now that we're instrumented, the question is, where are the applications that are going to transform the way we consume energy? I think again, a good idea at the wrong time is a bad idea. We're at the right time, I think, for energy. And so I think leveraging this new big data infrastructure there could be quite fruitful.
Bill?
Yeah, there's going to be an explosion in cheap sensors coming online. That's going to be a huge opportunity for people to tap into what might be public data, or I guess the privacy watchdogs will start worrying that these sensors are going to be collecting, 1 billion times as much information as Google ever did with their van driving by. So it's an exciting opportunity, and we have to be prepared for it with all sorts of standards around how we track this information flowing through.
They're getting
economy.
cheap enough. I was even thinking about, you could actually get the help of pigeons in New York City to carry sensors around. I mean, when it gets to the point where you can put cameras and low power devices on virtually everything, what happens then? And it's not that far away.
Yeah, we've talked about this Internet of Things, and another example is, there's some cities in Europe that have pollution monitors on their bikes, on these bikes that walk around. So it's lots more data being generated. Luca, I'd like to come back to you because, as you mentioned, right, there are a tremendous amount of imagination about what can be done, and sometimes maybe your customers don't know as much as you do, et cetera. So what is it that you wish your customers understood if they were actually to be able to capture more value from this stuff?
Well, I think the one thing that we run into regularly is, I think that people underestimate the degree to which this kind of infrastructure can change their business fundamentally. And I think underestimating that is to perhaps miss an opportunity or to be overwhelmed by the changes as they occur. And so I think, when we deal with customers who have existing data science teams, I think they understand it a little bit better, but for some who haven't quite gone that far, I think they don't quite realize how much this could change what they do. And I think, and the other thing to think about is that I think rather than any given stovepipe, what we're about within analytics and big data is about predicting things, so predicting the future. And if it were easy to predict the future, you'd bake it into an application called Predict the Future, and it might be called Oracle. But but it isn't, and context changes, human beings change, and so therefore we need these data scientists, and we need to. So I think rather than I think there's some behavior out there which is like buy the app that makes big data happen. It doesn't work that way, and so to some degree I think we're in a kind of an early stage of what should be an explosion of new activity around this science of data, and I think recognizing that up front and understanding its ramifications is something that we're going to need to see happen more.
Well, let's let the audience recognize some questions here. So I think there are some microphones out there, and if you don't ask them, we'll keep going. So
one hand here.
we do have hands up. Of course, they are in the most inconvenient place possible. So go ahead.
While they're getting mic, I have a simple litmus test that I use with customers on understanding where they are on this journey of using analytics.
Yeah.
And if you walk in and the customer says, my business is unique, you know they're just starting the journey. They don't really understand the application of it. If they go, tell me what's happening in another sector, another industry, that I can apply to differentiate myself from my competitors, you know that they have really changed their thought process. Because as you were mentioning, so many of these algorithms, they really do cross over. So if you can have a physicist that can look completely at the problem differently and apply the same mathematics that they bring, you really got some maturity going on.
Oh, that's interesting. All right, go ahead with the questions.
So one of the emerging barriers seems to be data rights. So it's based on regulation, based on privacy concerns, based on people wanting to monetize their data. It becomes even more complex as you combine the data because there are rights and so forth on that. So I think that's going to be a barrier. If there are any types of technical solutions, I mean, just if we could even encode the rights of data in metadata, that would solve it, but that doesn't solve a bigger problem. So.
Gil, do you want to take that?
Yes.
Yeah, so I think, one thing that's just hopeless is that any of us are going to really understand the terms of service when you use this a service and you're trusting your private data. So there needs to be a solution. I guess maybe there hasn't been the horror story yet, or maybe there has been. But regardless, it's gonna happen eventually, and there's gonna be. It's just a matter of time before people take advantage of the situation. So there has to be a lot clearer privacy policies. And the only idea I have is that there has to be standardization. You shouldn't have to read these things. It should work more like source code, where there's a version 1.0 that everybody agrees that they understand, and you name it something. And if some company decides they want to deviate from it, well, then you call it 1.1, but you better be careful because nobody knows what 1.1 is, that you haven't had time. So I don't know. Somehow we have to force everyone to use standards for privacy policies, and then there will be some chance for us to understand where this is all going.
Next question.
So can you break down the subsections of big data? My sense is there's capture, there's integration, and there's analysis. What else is there?
Thoughts?
Well, certainly I think if we look at analytics, there are a set of phases with regard to the creation. There's a certain interactivity with data that's around understanding what's inside of it. First of all, so there's data profiling. Then there's the notion of modeling, in which you're actually looking to create a model of something you're attacking, a hypothesis. You look at how to create a model that represents that, and you test that model against the data that you have. And really there's a third phase, which is putting it into production or making it actionable and pushing it into a context where it can be useful. And so at every one of those phases, there's sort of different people and different infrastructure kind of engaged. I may have left something out, but we certainly see that kind of cycle in modeling, and certainly.
The one point I'd add is that more and more we are seeing not just these three phases, but a closed loop, where once you actually put it in action and your model's out there doing something, that influences the world.
Yeah.
And that it fundamentally invalidates your model because people know what your model's doing.
Yeah.
And sort of sometimes actively, for example, maybe a fraud detection system, let's say, and you model certain kinds of activities as fraud, and then they get flagged as fraud. The people who are doing fraud are running their own system at the other end and are fundamentally figuring out what you're doing. So that invalidates your fraud model. So it's more and more we are seeing closed loop systems rather than non-open loop systems.
Yeah, I think it's a really good observation. I think one of the things that we've seen in big data is this iterative real-time nature of analysis that didn't seem to be the case historical, which is you run the thing and you kind of wait till the next quarter to run it again, right? Now people think of big data as a continuous thing, where they're constantly using the data for the next set of actions that inform the data set again, the next set of actions. So I think that velocity is going to drive, I think, a lot of adoption of the technology.
And in fact, one of the interesting things about these closed loop systems is that the closed loops, if it has to be fast enough, you'll have to remove humans from it.
Yeah.
So the model has to learn itself and tune itself. So you can't have humans learning and tuning models. And I think that's going to be an interesting area that can evolve over time.
Yep. Although as an erstwhile human-computer interaction guy, I would say there are times when the human's in the loop, and this idea of visualization and making the rich data consumable is also important. Next question.
So my question is around data stealing, and
I'm sorry, data?
Once the data getting stolen from one place. Oh, closer. Okay, here we go. So how does the data get stolen from one place to another? At this time, what I understand is the companies with the biggest money or the resources are aggregating the data and collecting, and they own the data at this time. Whether it be Google mapping up every street or every satellite that goes around the world, mapping everything. The countries or the data that nobody really knows that their data being collected, they own the data at this time, right? At what time the data becomes domain-centric, a country-centric, or a people-centric? At what point we think data can cross borders, or for that matter, generations. If we had just started collecting the data, a generation goes by, and the old times books used to fade, people used to forget. It just is written on the stones, and that's it. But the data will stay forever for us. So.
Well, it's an exciting opportunity that we won't lose an entire generation's worth of data. I mean, I think, you know, like one crazy idea is that if somebody leaves this Earth onto the next one, that they should probably leave their body of data so that the rest of the medical community can, you know, predict who else needs help. I know that's not your question, though. See, I'm the wrong person to advocate from the privacy side. Now, I should say that Factual doesn't. I mean, privacy right now for us it's a third rail. So we have only information. We don't have information on people. It's just on businesses that all want to be found and all want to be known. So we haven't really had to broach the subject of will Factual build the universal person database. You know, maybe in competition with all of India. Eventually, the billion. But that's maybe a long time from now. So the question of how does information bleed? I mean, there's laws around copyright protection and there's privacy policies that supposedly protect people. I'd love to see people have more control with things like the kind of direction that the Locker project is going, where you subscribe to exactly who and what you want to be used with this, and it's stored in your own possession until you authorize somebody. But lots of good things are happening, like OAuth and improving privacy policies in some cases.
Yeah, I think ultimately, I mean, this policy questions come up a lot, and I think we have to separate that from the technology that is driving and why people are using the technology. I think policy always lags a lot of the technology changes historically, and I think will happen, and I think there's a lot of ways it can happen. Hopefully, the user will get more empowered to do what they want with their data. And I think that's one of the changes that historically hasn't been the case, where you give your data and someone else has, and they can do whatever they want. Hopefully, over time, as data gets democratized, the individual will have the ability to kind of have a voice in where his data goes. And I think the value of big data, as we talked about, is the ability to intermingle data and open it to users when you want to open it. So I think you don't want to close it off in some ways. So you just want to empower the people that have the control to have control.
I think a number of these topics actually kind of infer that data products companies that specialize in taking these data and turning them into some composed artifact that could be used in applications. I think those can be a powerful force to make some of these problems more tractable, because once you get bodies that are making money from data, it first of all reduces the requirement for data science, because you have fewer people doing. Not everybody needs to do 6 terabytes a day of Twitter data to compute sentiment, right? You should do that kind of once or twice or 3 times. And at that point, when we start getting these data factories, data product factories, then some standards might emerge. It might be easier to sort of track what happens.
I actually think our problem is not the commercialization of that data. And so I think in the commercial sectors, we actually can find ways to govern ourselves, and we can, the pressures will evolve and we'll deal with that. I think our bigger concern we have to watch out for is the sovereign governance of that, where countries can decide that they can come into a cloud infrastructure and they can own all that data. So if we're going to spend energy, it's much more around the sovereign rights of governments to have control over our personal data than it is around the commercialization and use of that data.
Next question.
I'm curious, at least for the I'm curious for the larger companies on the panel, where and how are you using big data today, and what kinds of unique insights is it providing for your business?
Well, I can say, being part of a large company, recently from a startup, EMC is some, 50,000 people. But the key thing is that we've got a lot of products that are out in the field that are generating data. So one of the things we did internally is we had our own innovation awards, where we awarded people who had ideas within the company on ways to use analytics to help improve their life and business. And we had a couple of really strong entries, one of which was taking all of the EMC product data and streaming in, kind of landing about configuration changes, like what keystrokes do what, and then doing after analysis and active analysis to figure out which keystrokes yielded what results and in what ways could those be reused for other customers to help guide them as they're encountering an event that might be similar. And that's just a very powerful but very simple way to leverage big data infrastructure to process, tens of terabytes of data, every week, and do it on a regular basis to improve the product inventory.
Speaking for another large company, the Walmart, the two things that we care most about are our customers and products. And we use big data to learn more about our customers and about products. I mentioned one example, Shoppycat, the Facebook app that we just recently launched. Another is the Social Sense project, where we try to look at social media and blogs and search volumes and so on, and try to figure out what products are becoming interesting, and are they and we have this project called a store of the community, where we are trying to figure out are there specific geographic areas whose product needs are different from other geographic areas, and if so, should the product mix in our stores be influenced by what people are saying in social media, for instance? So things of this nature. So it's all about products and about customers. Those are the two main things that we care about.
Next question.
I wanted to touch on the issue of data provenance and data integrity. And, clients I talk to, there's still a lot broken in the enterprise today. A lot of data issues. And now I'm adding sources and the volume's growing, and this whole big data issue looming out there becomes a bit overwhelming. And I think Luke alluded to that. I sense that there's a lot of investment and a lot of effort going into analytics, into visualization, perhaps into the base platform. But I don't read or hear a lot about infrastructure, data management related tools that will improve the provenance, the integrity, the issue that the clients that I talk to have today. Can we comment on that, or would you guys like to talk a little bit about it?
Yeah, I think, Keith, you probably have got something on that, and then certainly Chorus and what we're doing there.
It's true. If you look at what's happening with our customer base, we see a couple of different things. One is their investment in data quality tools, data integration, data federation, master data management continues to be a large growing portion of our business. So the investment there continues to grow. People understand that moving latency out of that pipeline of managing data is one of their biggest challenges. If we can move to do 1 billion rows in 6 seconds, but it takes them 3 weeks to get the data there, we really haven't solved the problem yet. So that's one of them. And then the data governance, the data lineage becomes one of the bigger issues. I think people are finally getting over this idea of one version of the truth, just have one copy, isn't playing out. All right, so you're going to have a lot of copies of the data. So now how do you facilitate that in a governance structure so you actually know who has what. And that's some of what's going on in this idea that you need to have a collaboration tool so that you can find those people who are doing the interesting pieces with the data that's spread throughout the organization or out in the cloud.
Yeah, I think the key thing...
I'm sorry. Innovation and integration and federation. Is it more of the same, or do you see a lot of innovation in that space?
I think we're seeing a tremendous amount of innovation internally. In fact, we think this whole area of master data may turn into a whole new area for master data analytics, where how do you feed these systems that are doing the analytics, that are doing the closed loop, in a much different way than you think about master data management today feeding the traditional EDW. I think that's going to be a place where you're going to see
It requires a whole new level of agility to be able to recognize data structures as they're coming in, and those that are useful, track them, and then augment them as they progress. And I think, to Keith's point, it's an old field, but it's taking on new life in the face of this rapid acquisition of new data sources. So big data is not just size of one given data set, it's the number of data sets in addition to that. And, Anand, as you're talking about these, models that self-tune and discover, I think it's an even more important element of that.
Yeah, I mean, I like the question because I think it's an idea that's a little bit technical and not at all mainstream, but I think incredibly important. That society basically wants to see numbers as black and white, but the reality is that there's confidence intervals. The data point was 10 plus or minus 2, and that plus or minus 2, you can't store it anywhere, so it gets lost. And you also don't know who put that data point in, so you don't know really how much to trust that source either. And hugely important decisions get made all the time on these data points that we'd all like to be black and white, but they really aren't. It's an important issue. That Factual, I mean, we've tried to do our little part. You double-click on any cell. It looks like a spreadsheet, but when you double-click on it, we show exactly what all the opinions about the data are, because we want to show that it's really a probabilistic world, not a clean world at all. And we show you all the sources, and we show you what truth we extracted from it.
On every data point, every cell?
Every cell.
That's amazing.
It's a very interesting area. In fact, I know there is a research project going on at Stanford in the Info Lab around data provenance and how to maintain provenance as you do data integration and queries and transform the data. It's a challenging research problem that a lot of people are working on.
Great. Next question.
Do you anticipate a tipping point at which the supply of managing the data would not keep up with the demand of needing to manage it? Something of a deadline or a Y2K kind of effect? And if so, when would you project that would happen?
Well, kind of a doomsday of data deluge.
in fact, let me take that. I mean, in fact, we are there right now.
And how are we monitoring that? I mean, how would we know?
Well, the rate at which data is growing today is faster than the rate of data growth today is faster than Moore's law already. And it's definitely faster than the rate at which network bandwidth is growing. So data growth is already faster than both Moore's law and network network growth. So in one way, we are there already. But and that's why we have to innovate and create these new ways of analyzing data that don't rely and come up with new computing infrastructures and algorithms that can, in fact, cope with the huge amount of data that we get, despite the fact that it's growing faster than the growth in computational power already.
Or ability to store, right? If you add up all the disk drive platters and all the solid state, and you compare that to the amount of data that's actually being generated, you can't store it all even. So
yeah, well, storage fortunately is one of those things that does seem to be keeping up, but computational power is definitely not keeping up.
Yeah, I think the tipping point, I agree with that. The tipping point is what's causing the innovation, I think, in many ways. I think we're at this point where there's a gap between the amount of data and how we can manage it. And I think that's what's a lot of the startups and entrepreneurs are trying to fix that gap.
I think to that point, data has a certain inertia. And so if you're going to move a terabyte of data from point A to point B, it gets harder if that becomes 10 terabytes of data and so on and so on. And the infrastructure, the networks that connect these systems together aren't improving fast enough to make that any easier. And so, for instance, the technologies we've just implemented over the last decade are oriented around process in place. So send the processing to the data. And another principle is anytime you touch that data, you should be adding value to it. And so it's changing the way the value chain of data moves. And all of our infrastructure and our processes are geared around that. I guess your question, though, is whether that will stop keeping up with the pace of data that people are interested in, and if so, things will get more expensive. And I don't have a clear point of view on that.
Right. So about 10 years?
Next question.
So I heard a lot about healthcare, and being a healthcare guy in my recent past, I felt compelled to share a very quick story around big data. Big data in healthcare has been happening for a while. Before there was a label called big data. In 2006, for example, I worked for the largest integrated health plan in the world. And we started doing big data. The magic didn't come just from the petabytes of data we had, but from the subject matter expertise. Our physicians understood what that relationship of the data, and they created a model that related clinical data with pharmacy data, with office visits, with outcomes. And then we had actual scientists, mathematicians, who understood to create the mathematical models to crunch the data with that. But the reality of it, in order for it to take hold and do innovation, because we were such a large company, we actually spun it off as a separate company, totally away from our walls, not subjected to our rules and our processes and our internal mechanisms. And now it's probably the most successful predictive analytics in healthcare in the world. It's called Archimedes model. Check it out. So innovation really can happen, but it has to be done in the context to give the freedom to the subject matter experts and the computing capacity. Sure, it cost me more money than it would have cost me now because I didn't have Hadoop at the time. But it wasn't that bad because it's over $1 billion business now, and I spent about $30 million putting it together. Hadoop would have made it much easier. So this is a plugin for Hadoop.
Thank you. And if we could continue to have questions, that would be great. Next question, please. Yes.
Yes. Anand referred to Jim Gray. About 15, 20 years ago, he talked about the problem of terabytes spelled T-E-R-R-O-R because of the challenges of being able to deal with data that big at that time. I wanted to ask the panel basically three things. When you say big data, how big is big? How does that size end up affecting the need to be embarrassingly parallel in the algorithms that you use in dealing with it? And what constitutes a good answer when you have a problem, when you have that size data?
Yeah, certainly big. I mean, we already talked, I think, about how big data problems. It's a big squishy term. And big data is more than just the volume and size of the data. I mean, for instance, 30 gigabytes logistic regression algorithm takes 27 hours on a single computer, but when run on 32, it takes 60 seconds. And so even though it's 30 gigabytes and it fits in RAM, that's a problem that we'd characterize because of its complexity as requiring the parallelism to be exploited. I think bigger than previous generation non-parallel infrastructure can handle might be a useful definition. So anything that blows you out of the old way of doing things.
Next question.
Yeah, so my question is around the ROI of big data. So at what point do we think that we have this white elephant that we've invested in and we're not getting the money or the returns from this investment? So I know everybody's trying to build their own silos of big data. So at what point do we realize this is not worth it?
I'm not sure I understand, because every customer that we're working with is investing because they actually can see the return on investment. Those that are approaching it directly from a business problem, a question that they could either by being able to answer it much faster, completely change the business, or by answering something they couldn't answer before. So I'm having trouble with the question because all of ours are driven from an investment from the beginning that pays off on the investment of the infrastructure and the new analytics.
One of the reasons why I think the big data wave has had this velocity is because for a lot of customers, it's a value creation opportunity. There's real revenues and there's real sales and there's real forward-moving things as opposed to cost savings and minimizing operational stuff, right? I think that's the reason why enterprises are really attracted to a lot of the big data tools, is because they're saying, hey, how can I not only beat my competitors, how can I make more money? Anything that's tied to making more money tends to sell a little easier. And I think that's really, so I think the ROI equation actually is very strong for a lot of the big data applications.
Does anyone in the panel have a failure story? an attempted investment which didn't pay off.
There's none in our portfolio.
I mean, in terms of failures, the one thing that I would say is that when you have big data and we're doing speculative kinds of things with the data, we always try to do things so that many of the questions that we ask tend to have negative answers, and tend, many of the hypotheses that we try out don't work out. Otherwise, you're not trying hard enough. So it's important to build a big data infrastructure that can support multiple different kinds of applications, and so that even if a few of the things do fail, there are other things that will succeed. Because I think it's almost an article of faith at some level that when you have a lot of data, there is value there, and if you ask the right questions, you're going to get a lot of value. It's quite possible that some of the questions end up giving you negative answers, but then there are going to be others that do give you positive answers.
Now, since we're blending faith and science, I think there's an interesting opportunity. We did have an example where we had a telephone company, and they're tracking loyalty and whether customers are going to leave their network or not. And they had a big problem, right? A lot of money was going out the door. And so the first thing that the data science team did is they looked at call quality. And they said, surely these people are leaving because the calls are dropped. And what they found is actually a slightly negative correlation between call quality and customer loyalty. In other words, customers are staying a little bit tighter to the company if they have bad call quality. And you looked at that and go, head scratch. And ultimately, the only thing I could think of is perhaps it's good phone, bad telco, right? The iPhone, of course. But in the end, with some faith behind the idea that there is something in that data that's going to explain this, they went to the next level and used graph computation. So they used actually a social network analysis to figure out call circles, and found that by analyzing the call circles, which arise directly from the data, you could infer that if one person in a call network left, then the others in that network were 7 times more probable to leave as well. And so that became quite predictive and went into action, and saved them $40 million a year immediately. But it took an article of faith to cross that boundary, and keep plugging at it.
Yeah, I think it's important when conducting experiments that no answer, you learn something. So that's quite powerful. One more.
Does the importance of data quality go away? Is having the best data irrelevant, and having the most data the salve, the savior?
Quality versus quantity.
Well, so in customer intelligence, in the marketing side, quality usually will rule, from our experience. In the fraud side, right, you need all that dirty data, because actually that's how you're figuring out how they're gaming you. So it's a different answer for the two different problem sets. I think we haven't pointed out tonight that one of the things that is occurring is because so many of the systems are automated, some of the challenges around dirty data are starting to disappear. When you have sensor networks and you're not getting the failure in the sensors, and you're able to detect when those failures happen, the data actually over time, as we get more volume, is actually getting cleaner.
Maybe one way to answer this. I think the promise of big data is you don't have to choose. You don't have to know what's the good stuff and what's just everything else. If you can have an efficient way of processing as much as you can, then you can iterate towards figuring out what's good data. Because I think one of the nice things where the promises is that you don't have to know in advance which data is really the valuable ones. And you can learn that through the iterative real-time feedback loop that we've been talking about. So, hopefully you won't have to choose as a data scientist what's good and what's just not good.
A follow-up on that is that cleaning up a lot of data is itself a big data problem, and sort of it's a question that begs itself. Right? How do you know that it's a clean data set unless you've taken a big data set and cleaned it up in the first place? So clearly you need a lot of data to begin with, and in general, fresh data is more valuable than stale data, and fresh data means you probably haven't had time to actually go clean it, so it's usually going to be dirty to begin with.
So speaking of fresh, dirty data, it's time for the lightning round. So I'm going to ask a quick set of questions. You have to answer very quickly, otherwise you will be shamed. Ready? What's the biggest store of data of which you're aware?
Biggest store of which I'm aware, single table, Catalina Marketing.
Big store of data? I'll plug Common Crawl. We're crawling the web and making it available. 5 billion pages are sitting on Amazon, available for anybody to use.
Okay.
Facebook.
Large Hadron Collider.
There's a big sky catalog, some kind of astronomical data set.
What's more valuable, data or analytics?
Analytics.
SaaS.
As I stated, I love data.
Data.
People, data.
Data.
I got lots of market opportunity.
What's the most valuable source of data that people aren't thinking enough about?
Fast, before the bell rings. I don't think they're paying enough attention to the attribute information around customers that's available to them.
Still crowdsourcing. There's so much more to get.
Maybe there's more to do in mobile.
Yeah, mobile crowdsourcing, sorry.
Social.
What business or other problem is best suited to being solved using big data? But I'm going to come back this way now.
Okay, can you repeat the question? I thought I had time.
Too far away.
You cheated. So.
Most important big data problem. Most important big data problem.
How to combine big data and fast data into one system?
Econometrics.
I think healthcare.
Yeah, predictive healthcare.
I have to go to healthcare.
How long will it be? Cheating now. How long will it be until big data becomes the basis of competition in most industries?
It already is.
It already happened.
Yeah, happened.
There's data scientists, athletes waiting to get created.
Already passed.
Wow, you guys are pretty bullish on this. What's the biggest obstacle keeping organizations from capturing value from big data?
Skills.
A lack of data-driven culture.
Not enough data scientists.
Process, culture.
Skills.
People stuff. Very interesting. Present company accepted. Who's the smartest person you know thinking about big data? Anand.
Somebody at Google, I'm sure.
You didn't pick. Please note, he did not pick his advisor.
Yeah, I like Bezos, you know.
Oh, someone at Facebook.
These anonymous people, okay?
I had an inspiring chat with Max Levchin today. He's into data now.
Our founder, Dr. Goodnight.
Company guy. All right, other than the US, from which company will the next major big data company come from? From which country will the next big data company come from?
China in the energy sector.
Pass.
Geography? You don't have any map?
You can throw
China or India?
Okay.
China.
Yeah, China mobile.
Could come from anywhere in the world. So.
That's a pass.
That's a pass. I will note that. Which company is most threatened by the rise of big data?
Any company that doesn't do anything with big data.
Oh yeah, that's a loaded question. I'd have to say, that's a tough one. Yeah.
King.
I think every incumbent's in danger.
One of those ones our government doesn't like.
I think the financial sector keeping up with the changes can be disintermediated quickly.
All right. Which company, other than your own, is best positioned to capture value from big data?
Company other than our own. I think it's us, but it's hard. The government sector.
We're talking. Last question was company, not country.
Correct.
Okay. No wonder. Okay. Question again.
Which company, other than your own, is best positioned to capture value from big data?
Oh man. I mean, what do you call the four horses? You know, Amazon, Apple, Google, Facebook. I mean, there's so much more for them all to do.
Any one of the Accel portfolio companies? Take your pick.
Technically not your own, I guess.
Right.
Capturing, I think the geolocal data, if that opens up, so there are companies that are specializing, and I won't name them, in finding ways to get that data out. And once that becomes available, they can capitalize on it.
Anand.
Facebook, definitely it's the most valuable data in the world. It's data about people and what they're doing at every second in their lives. So that's, I think.
Great.
If they don't, their value crashes.
Thank you very much. Karen will come to us and for the close. But thank you so much to the panel.
So on behalf of the Churchill Club, our audience, our sponsors, I want to thank you for sharing your views so candidly. Michael, you rock as a moderator. Thank you again. There's a small gesture of our esteem. Please accept this smoking hot Churchill Club t-shirt. Please wear it in good health. I'd like to thank our sponsors again. We really appreciate the support of EMC, SAS, and Brocade. If you would like to receive a copy of a SAS white paper about big data, simply write the word yes on the back of your business card and take it out to the registration table. And there's also a hard copy out there for you of the McKinsey research report that Michael was involved with. So please avail yourself of those resources if you're interested. And thank you all. You've been a great audience. See you next time. Good night.